A-level statistics, measures of spread, variance and standard deviation. Let's have a look at what variance and standard deviation are. Now so far we've measured spread using the range or the interquartile range. With either of these we're only using two values from the data to express the spread of all the data. This isn't very good because we really want to know what's happening with all the data. So we need a method that uses all the data. Well, one method, which we won't actually be considering in future, is called the mean absolute deviation from the mean. Using this method to measure the spread, we find the mean value of the data, that's x bar, and then find the mean of the differences between x bar and each of the original data values. That is, it's the sum of the modulus of x minus x bar all over n. Now the modulus means the positive value, the difference between. X minus x bar is each piece of data minus the mean of the data. So we sum those and divide by the number of pieces of data. So for example, to find the mean absolute deviation of the numbers 2, 3, 5, 4, 8 and 2, we first find the mean of those numbers. So x bar is equal to 2 plus 3 plus 5 plus 4 plus 8 plus 2 all over 6, which is 24 over 6, or 4. Then we find the mean absolute deviation. That means we find the difference between each of those numbers and the number 4. So that's the modulus of 2 minus 4 plus the modulus of 3 minus 4 and so on up to the modulus of 2 minus 4 all over 6, which is 2 plus 1 plus 1 plus 0 plus 4 plus 2 all over 6, which is equal to 10 over 6 or 1 2/3. Now it turns out to be very hard to work with the mean absolute deviation, so instead we use what's called the variance and the standard deviation. Now the variance is similar in that in the first method we use the modulus sign to make everything positive, but another way to make all the terms positive is to square them. So we define the variance as being sigma x minus x bar all squared over n. Now what that is, it's the sum of each of the terms minus the mean squared divided by the number of terms. Now the problem with the variance is all the terms have been squared, and that means we've got a measure of the square of the spread. So we need to take the square root of the variance, and that's called the standard deviation. So it's the square root of the sum of x minus x bar all squared all over n. Now it turns out this can be rearranged as the variance of x is equal to the sum of the x squareds over n minus the mean of the data squared. So we've got the variance of x is the sum of the x squareds over n minus the sum of the x's over n all squared. And the standard deviation is the square root of that. Now it's easy to remember this because we can say the variance is the mean of the squares minus the square of the mean. Let's look at an example. Find the standard deviation of 2, 3, 5, 4, 8 and 2. Now we need to find two things, the sum of the squares of the numbers and the sum of the numbers. Now the sum of the squares are 2 squared plus 3 squared plus 5 squared plus 4 squared plus 8 squared plus 2 squared, which is equal to 122. The sum of the numbers are 2 plus 3 plus 5 plus 4 plus 8 plus 2, which is equal to 24. Now if we substitute them in the variance formula, that gives us the sum of x squared over n is 122 over 6, and we take away the sum of the x's over n squared, which is 24 over 6 squared. Now that's 20 1/3 minus 16, which is 4 1/3. So the variance is 4 1/3, and the standard deviation is the square root of 4 1/3, which is 2.0817. Let's have a look at some problems involving variance and standard deviation. Now we have two formulae which we're going to use. So in example 3, we're asked to find the variance and standard deviation of the following list of data. Now, to solve this, first of all we can count that there are 10 pieces of data, so n is equal to 10. We can then add up all the data, and that's equal to 106. And then we have to add up all the data squared. So we have to add 25 plus 49 plus 144 plus 196 plus 324 plus 81 plus 144 plus 81 plus 64 plus 144, and that comes to 1252. Now we have the variance is the sum of the x squareds divided by n minus the sum of the x's divided by n all squared. So that's 1252 divided by 10 minus 106 over 10 all squared, which is 125.2 minus 10.6 squared, which comes out to be 12.84. So our variance is 12.84. And to get the standard deviation, we simply square root that. And that gives us the standard deviation is 3.583. Now let's have a look at a slightly harder example. We are given a set of data and we're told that the sum of all the data values is 162. We're told that the sum of all the data values squared is 5,724. And we're also told the standard deviation is 15. We have to find the number of data values of x. Well, this is a slightly harder problem, but let's have a look at it. To solve it, if the standard deviation is 15, then the variance is 15 squared, which is 225. Now we know the variance is equal to the sum of the x squared over n minus the sum of the x values over n all squared. So 5,724 over n minus 162 over n all squared is equal to 225. Well, if we expand the bracket, that gives us 5,724 over n minus 26,244 over n squared is equal to 225. And if we multiply all the way through by n squared, we get 5,724n minus 26,244 equals 225n squared, which can be rearranged into a quadratic 225n squared minus 5,724n plus 26,244 equals 0. Now we can't factorise that, so we'll have to use the formula x equals minus b plus or minus the square root of b squared minus 4ac over 2a, and we're substituting in a is 225, b is minus 5,724, and c is 26,244. Well, it's a long expression, but it simplifies down. X is equal to 5,724 plus or minus 3,024 over 450, which works out at x equals 19.44 or x equals 6. Now we can't have a fractional number of terms, so the only valid answer is x equals 6. So there are 6 terms. Let's see how we can deal with group data. In example 4, we're asked to find the standard deviation of the data given in the table. Now the table has 4 different numbers, 5, 6, 7 and 8, with frequencies 4, 8, 5 and 3. Now to find the standard deviation, we could list all the data and solve it like we did the last problem. But from the table we see that we've got 4 number 5s, 8 number 6s, 5 number 7s and 3 number 8s. That means altogether we've got 4 plus 8 plus 5 plus 3 numbers. So n, the total number of data values, is 4 plus 8 plus 5 plus 3, which is 20. Similarly, if we want to work out the total of all the values, we can say we've got 4 5s plus 6 8s plus 7 5s plus 8 3s, which is 127. And if we want to find the total of all the values squared, we've got 4 lots of 5 squared plus 6 lots of 8 squared plus 7 lots of 5 squared plus 8 lots of 3 squared, which is 825. And now we can work out the variance. We want the sum of the x squareds over n minus the sum of x over n all squared. So that's 825 over 20 minus 127 over 20 all squared, which is 41.25, take away 40.3225, which is equal to 0.9275. Now the standard deviation is the square root of the variance, which is 0.9631. So our answer is the standard deviation is 0.963. Now alternatively, we could solve the same problem by drawing a larger table. If we add together the numbers in the frequency column, that's column F, we get the total number of data, 20. So sigma F is the sum of the data, which is 20. Now we add an extra column x times f, which is the value times its frequency. So that's 5 times 4, which is 20, 6 times 8, which is 48, 7 times 5, which is 35, and 8 times 3, which is 24. Now if we add the numbers in that column, that's 127, which is the sum of all the data. And we add a fourth column. We add the column x squared times f. So that is 5 squared times 4, which is 100, 6 squared times 8, which is 288, 7 squared times 5, which is 245, and 8 squared times 3, which is 192. Now if we sum all the terms in the x squared f column, we get the sum of all the squared data. So the sum of x squared f is equal to 825. So now we have a formula. The variance is equal to the sum of all the squared data, that is sigma x squared f, over the total number of data, which is sigma f, minus the total of the data, which is sigma xf, divided by the number of data, which is sigma f, all squared. So this gives us the variance equals 825 over 20 minus 127 over 20 all squared, which is equal to 0.9275, and as before we get the standard deviation as the square root of that, which is 0.9631. So again, our answer is the standard deviation is 0.963. So for the variance and standard deviation of group data, we've got two new formulae. Remember, the variance is the sum of the x squared f over the sum of f, minus the sum of xf over the sum of f, all squared. And the standard deviation is the square root of that. If the data is continuous, then it will almost certainly be put in groups. So in example 5, we're asked to find the variance and the standard deviation of the data given in the table. What we need is a larger table. Well, to solve this, we first need to work out the number of data values present. Now that is the sum of f, sigma f. Well, that's 9 plus 13 plus 23 plus 37 plus 51 plus 17, which is equal to 150. We then need to work out the mid-value of each group. Now the mid-value of 30 and 40 is 35. The mid-value of 40 and 50 is 45, and so on. So the other values are 55, 65, 75 and 85. These are estimates of the values of x. Next we need to sum all the values of x. Now we have 9 data with a mid-value of 35, so that's 9 times 35, which is 315, and 13 with a mid-value of 45, so that's 13 times 45, which is 585, and so on. 1265, 2405, 3,825 and 1,445. So the sum of all the values of x is sigma xf, and so we add all the numbers in the xf column, which altogether comes to 9,840. And finally we need to find the sum of all the x squared terms. So that's the sum of the x squared f, or sigma x squared f, which is 9 times 35 squared, which is 11,025, plus 13 times 45 squared, which is 26,325, plus 23 times 55 squared, which is 69,575, plus 37 times 65 squared, which is 156,325, plus 51 times 75 squared, which is 286,875, and 17 times 85 squared, which is 122,825. And then we add all of those, and this gives us 672,950. So sigma f is 150, sigma xf is 9,840, and sigma x squared f is 672,950. Well, we can substitute them in the formula for the variance, and that works out to be 182.9733. So the standard deviation is the square root of that, which works out to be 13.52676. And so we can say the standard deviation is 13.5 to 1 decimal place. Let's have a look at an example of combining data. Example 6. 2 classes in a school set a maths test out of 50 marks. Class A had 25 children. Let's label the marks X. And we're given the sum of all the marks X is equal to 866. And the sum of all the marks squared, x squared, is equal to 31,892. In Class B with 32 children, if we label the marks y, then the sum of the marks, sigma y, is equal to 1,031, and the sum of the marks squared, sigma y squared, is equal to 37,581. Now we're asked in part 1 to find the standard deviation of Class A. Now we have the variance of the class is the sum of the x squared over n minus the sum of x over n all squared, which is equal to 31,892 over 25 minus 866 over 25 all squared. And that gives a variance of 75.7504. So the standard deviation is the square root of that, and it turns out the standard deviation is 8.703. In Class B, the variance is equal to 37,581 over 32 minus 1,031 over 32 all squared, which works out to be 136.358. Now the standard deviation is the square root of that, and so the standard deviation is 11.677. Now in part 3 we want to put both classes together. So together the total number of students is 25 plus 32, which is 57. So n is 57. Now if we add the marks, we can call that sigma z. We have in one class 866, plus in the other class 1031, so that gives a total of 1,897. Sigma z squared is equal to the sum of sigma x squared plus sigma y squared. That's 31,892 plus 37,581, which is 69,473. So if we substitute that into the formula for the variance, together we get the variance is equal to 69,473 over 57 minus 1,897 over 57 all squared, which works out to be 111.219, and the standard deviation is the square root of that, so the standard deviation is 10.546. Let's look at one more example, example 7. Now the daily temperature was measured over the first 6 days of a week. The mean temperature was 8.5 degrees and the standard deviation was 2.5 degrees. On the 7th day the temperature was 19 degrees. Calculate the mean temperature for the week and the standard deviation for the week. Now to solve this, to begin with, let's consider the first 6 days. Now in this case n is 6. The mean temperature, x bar, is 8.5 degrees, which means the sum of the temperatures is 6 times 8.5 degrees, which is 51 degrees. Now we're also told the standard deviation is 2.5 degrees, which means the variance is 2.5 squared, which is 6.25. And we know the variance is equal to the sum of the x squared over n minus the sum of x over n all squared, which is the mean squared. So sigma x squared over n minus the mean of x squared is equal to 6.25. So sigma x squared over 6 minus 8.5 squared is equal to 6.25, or sigma x squared over 6 equals 6.25 plus 72.25, which is equal to 78.5. So sigma x squared is equal to 6 times 78.5, which means sigma x squared is 471. Now, for the 7 days, we've got the sum of the temperatures, sigma x, is equal to 51 degrees plus 19 degrees, which is 70 degrees. So the mean for the 7 days is 70 degrees over 7, which is 10 degrees. So the first part, the mean temperature, is 10 degrees. Now we've also got the sum of the x squareds is the sum of the x squareds for the first 6 days plus 19 squared, which is the temperature for the 7th day, which altogether adds to make 832. Now if we substitute the numbers into the formula for the variance, we have the variance is equal to 832 over 7 minus 10 squared, and that works out to be 18.857. So the standard deviation is the square root of that, which is 4.342, and so the standard deviation is 4.34 degrees.